Okay, so what about this here then? What do we got going? If f of x, the red function's the parent function, what's g of x?
Oh.
Plus 7, good.
Plus 3.
Minus 3, okay, good. And the reason we get that is because h and k have values of, those are just the coordinates of that point right there, aren't they? Right, that's how far it's been slid from 0, 0. So that's just negative 7 and negative 3, right? No biggie. Okay, how about this? So here you're given a parent function is f of x equals x squared, which is just a parabola. So we want to know the vertex of this function if we do this to it, if we transform it to become g of x. What's the location of the vertex going to be? What are we going to get?
So right 3 and down 5.
Okay, so the coordinates would then be,
Negative 3, negative 5.
would just be 3, negative 5, right? Does that make sense? So just the values of h and k, that's it. Okay, questions on that? Okay. Let's see. So everybody real quick, write this one down in your notes. So f of x is the parent function. G of x is going to vertically stretch f of x by a factor of 5, translate right by 2, and translate up by 3. Okay, so what's that going to look like? So Zach, what's that going to do? So if we start off with plain old f of x and we're going to do this stuff to it in this order, what does vertically stretching by a factor of 5 do?
Multiplies it.
Say it again. Multiplies it. Okay, so we're going to get a 5 out front. And then Trent, what's translating right by 2 going to do to the function?
Subtract 2.
Okay, so I'm going to subtract 2 from x. Good. And then up by 3, what's that going to be, Brendan?
Plus 30.
So how do I, if I'm translating up by 3, what do I have to do to the function? Say it again. Did you say it? Add 3, yeah. Okay, there you go. Perfect. Okay, that's it. I must have heard. Okay, good, good. Okay, same thing for this. What are we going to get with this guy? So same kind of thing. We're going to write g of x in terms of f of x. It's horizontally stretched by a factor of 5. Okay, we got to be careful with this thing. So that means that this part right here, horizontally stretched, horizontally stretched by a factor of 5. That means that the horizontal dilation factor, right? That's what we're multiplying by, is equal to 5, right? Everybody agree? Okay, we're stretching horizontally, we're multiplying horizontal distances by 5. Okay, but what does that tell us then? If that's the case, what does that tell us about B? It's got to be 1/5, doesn't it? It's got to be the reciprocal of the dilation factor horizontally. Okay, so let's kind of start writing this thing down then. So we're going to end up with g of x equals, I'm going to get horizontally stretching by a factor of 5 means inside the function, what do? Okay, I got to put some brackets and I'm going to have a 1/5 out in front of my x minus h, right? Okay, so if it's going to be reflected horizontally, what does that do? Negative. Makes b negative. Good. It actually is going to make both the dilation factor negative and b negative, right? Because they're just reciprocals. So then that becomes a negative 1/5, and then we want to translate it right by 10. So let's change. How do we do that? If I want to go right by 10, What do I have to do in here?
What's the negative?
Because it's the negative, here, let me color code it. That goes from reflected horizontally gives us the negative. Okay, because that makes B negative. Shane, how about translating right by 10? What's that telling us?
-10.
Minus 10, good. So we're gonna do, and what you mean, I assume you're saying it's gonna be x minus
Yep.
10. Perfect. Okay, so that's the value of h, isn't it? Okay, and then finally, up by 1, Anna, what's that gonna be? Plus 1 outside at the end. Good. Okay. I think you guys are really getting this stuff. It's good. Okay, last one of these. This is kind of a doozy. A lot of stuff going on here. Take a second and just try this on your own, and then we'll go through it.
So I'm gonna stretch.
Okay, what do we think here? Kimberly, if we're going to horizontally stretch by a factor of 3, what's the horizontal dilation factor then?
In the very.
Okay, that you're thinking of B, right? The dilation factor. If we're stretching by 3, then we're going to have to multiply horizontally by 3, right? So that's 3. B is 1/3. Very good. Okay, Mackenzie, what about this part right here? If we're reflecting vertically, what's that going to do? Okay, it's going to, right, we're going to put a negative out front, aren't we? Because that's actually A, isn't it? That's telling us that A equals -1. So we got a lot going on here then. So G of X is going to equal, we've got our 1/3 out front. Well, actually, we've got our negative out front, the whole thing. Then we've got our F of 1/3 times, now what? Translated left by 4, what's that going to look like? Cam, what's that going to look like?
+4.
Plus 4. So we get an x plus 4, and then down by 8.
Yep.
Okay.
Yep.
Yep.
I say yep.
Okay, so I want to look at, let's see, one of these guys. Pull one of these up.
Dude, I hate games like that. Because then, and then you do something like 5 minutes and you're like, what happened? Or what I miss?
Okay, what about this? So here's f of x and g of x. The blue function is what? G of x is going to equal what in terms of f of x? Does the negative go times the whole thing or just times the x?
Just times X.
Just, you sure?
No, I don't know. This I was having trouble on.
Okay, so what do we think? What's this one going to be?
The whole thing?
The whole thing, yeah, because remember what we're doing here, we're going to multiply all of the output y values of the whole thing have to get changed so the y values become opposites. So, right, so instead of going up, we'd go down and vice versa.
That makes sense.
Okay, and the reason we're doing that is because it's reflected across the x-axis. Okay, so let's try one of those. Let me pull one up where we get... Come on.
Holy smokes.
What are the odds of that? Oh my gosh. I gotta go buy a lottery ticket. There we go. How about this one? So this time they're reflected across the y-axis. So what are we gonna do there?
X.
Good, we're just gonna trade all the x's for negative x's. Okay? All right, so okay, Ellie, how about this one now? What if I want to take this function, g of x, it's going to be a reflection of f of x right here over the x-axis. What are you going to do with that? So g of x equals, what do I do to this thing?
How do you say that?
Seventh root? Yeah.
Sure.
Okay, so you don't, and you don't have to be specific. Where am I going to put my negative sign here? For everything. In fact, I'm even going to have to put everything in parentheses, aren't I? Right? Because in this case, make sure everybody understands this difference. If I start off with just plain old f of x, so we haven't done anything yet. It's a seventh root of x minus 7 plus 6. Now look what happens. If I put my negative sign right there, what did I just do? What did it do to the graph? If I just put the negative, that would be a negative value of a, wouldn't it? Right? What does that do? It flips vertically, but it doesn't go clear over the axis, right? All it's going to do is just flip it over its vertex, or its special point, right? If I want to flip clear over the x-axis, I got to multiply the whole thing, the whole y value by -1. Okay, does that make sense? Okay, so what about the bottom one then? If I want to reflect over just the y-axis, what would I do? Good. So any x's that would appear, and the functions we're dealing with only have one x, but if I had a function that had like multiple x's in it, all the x's I would just replace with negative x's. Okay, so this one would then just look like g of x equals 7th root of a negative would just go right there. Okay? Make sense? Okay, how about this then? So these are the new ones I added. I added these to the reviews. I didn't have these in any of the previous assignments. I thought this would be useful for you guys to be kind of a first step for doing graphing stuff. When you look at these, the idea is you're going to pick out the values of the parameters. And once you know the parameters, then it should be easy to identify a graph. So these are the steps I think you kind of ought to go through when you're sketching a graph or choosing a graph or a function, right? Okay, so if we look at this one then, this is a square root graph, big deal, right? That's the parent function. But if the parent function is just the square root of x, we got to pick out the values of a, b, h, and k. So what's a? 4. 4. Yeah, good, because 4 is just the number that's out in front, right? So if a is 4, what's the vertical dilation factor?
4.
No, just 4, right? Remember, the vertical one, a isn't tricky. A is just what it claims to be. If a is 4, then that means you're multiplying vertically by 4, right? B is the one that's reciprocal. It's kind of messed up, okay? So what is, what are h and k? Those are easy.
2 and 5.
-2? You see why it's -2?
Yeah.
Okay, -2 and 5, because, now why is this? Think about what we're doing. We're just going to, if our parent graph is a square root, then our function is going to look like this. A times the square root of x minus h. But then if there's a b, the b has to go out in front of that, right? Plus k. So we're just looking at whatever number is being subtracted from x. Well, it's got to be a -2, doesn't it? Right? Because we end up with x plus 2. That's the same as x minus -2. Okay, what's b? What's b in this case? 1. It's 1. Good. And how do you know it's 1? It doesn't show up in there. Why is it 1?
There is nothing in front of the x that makes it 1.
Okay, good. It's something that normally would be multiplied. A's and b's are normally multiplied. So if they're invisible, they're 1s. H's and k's, they're normally added and subtracted, right? If those don't show up, then they're 0s, right? So b is 1. So what does that make the horizontal dilation factor? It's only 1, right? It's going to be the reciprocal of 1, which is just 1. Okay, good. Good, good. How about this one? So we got an absolute value function this time. It's the same game. Let's start off with h and k, because those are probably the easiest. What's h?
Nothing.
0, because there's nothing being subtracted from the x. What's k? Negative 2. Okay. What's a?
1/5?
Negative 1/5.
Oh my god. That's what I mean.
And so then, what's going to be the vertical dilation factor?
Negative.
Negative 1/5. Good. Horizontal dilation factor in B, in this case, B is what?
1.
1. So that's just going to be 1 also.
Okay.
Okay, how about this one?
Of
So this time, what are h and k?
0.
0. What's a? 1. Everybody see that? A is 1. So then the vertical dilation factor is 1, right? What's b?
Negative.
Okay, good. Negative 1/16, and that's important because that tells us that the horizontal dilation, or excuse me, the b is negative 1/16. So the horizontal dilation factor is
Negative 6.
negative 16. So that means that we're actually stretching then vertically, right? Even though b looks like a fraction less than 1, remember we're doing the reciprocal, we're actually multiplying by negative 16, okay? Last one of those, this is kind of a little bit of a tricky one. What are h and k?
7.
7, negative 1. What's a? Negative 1. Which means the vertical dilation factor is negative 1. So what's that doing?
Makes everything negative.
Flipping everything over
Good,
there.
it's just flipping
It's kinda like
vertically.
this.
Good, flipping vertically. What's b?
Negative. Or negative 1/3.
No, just plain old 1/3. There's my b, right there, right? And so that makes the horizontal dilation factor 3. So we're stretching by a factor of 3 horizontally. Okay? Good? All right. We could probably skip that one. So now let's look at, let's maybe go to a couple graphs. Being as I think this would be a better order. How about if we go, skip up here. Okay, let's try this one. Okay, so let's apply the same kind of thinking we just did to this. How come that won't? Oh, well, good enough. So what we want to do here, we just want to identify what are the values of the parameters, and that'll tell us, that'll allow us to go find the graph really quickly. Let's just demonstrate with an easy one, and then we'll look at some hard ones. So what about this? What are the values, what's the value of h and k?
7 negative 0. 7 and 0.
Oops. Okay, good. So it's 7, right? H is 7, K is 0. So those are the coordinates of the vertex, right? What else? Are there any other parameters that we know here? Any of the other ones that show up?
Negative.
Okay, so what's that?
It's like foot.
Okay, so we know A is negative 1, so that tells us our vertical dilation factor is negative 1. So it's just going to flip, isn't it? So there's not much going on here, right? This is one where this would be an easy one to find. We're just going to go look for vertex at 7, 0, and it's flipped. So right there. Does that look good? And it's not, notice that it hasn't been stretched or compressed vertically or horizontally, right? Whereas we normally go over 1 and up 1, this time we go over 1 and down 1. That's it. So we haven't stretched it at all. We've just flipped it. Does that make sense in terms of? Let me just show you one more thing. I just want to make sure I'm being real consistent with this. So our parent graph would start with that vertex. It would go over 1 and up 1, right? So we would end up with a plus 1 there. What we're getting instead is our transformed one goes down by 1, right? So that means that if we multiply A times the original, which was 1, we get -1. So A is just -1, right? The other way to think about that is the dilation factor is always going to be the final factor over or final value over initial value, right? When we're looking at dilation factors. So the final is -1, the initial is 1, so I end up with -1 for A. Does that make sense? So that's all consistent? Okay, let's try another one. So 8. Let's try 8. Okay, what about this one now? Take a second and identify the values of any of the parameters that show up there. Okay, Katie, tell me. Everybody, I'll call people, give me one value. Everybody gets to give me one value that I call it. So what's one parameter? -2 is which one? K. Okay, so K is -2. Okay, somebody else help me out here. Zach, give me another one.
-2/5.
Which one's that?
That's the vertical dilation.
Okay, so that's
That's
A,
what it is.
we'll call it A, same thing as vertical dilation factor, isn't it? So A is -2/5, so the vertical dilation factor is -2/5. Last one, Trent.
The H, or, is it H
Yeah,
is +5?
is which one? H is, you almost got it, but it's H is what's being subtracted from X, right?
5.
So it's
Subtract 5.
-5, right? Because it's always going to be, remember, H is the one that's goofy. H is equivalent to the horizontal translations. It's always going to be the opposite of whatever the,
Oh, yeah.
does that make sense?
Because when you go on the line, you know, you go backwards.
Exactly, exactly. So then we end up with vertex at -5, -2, right? And then our vertical dilation factor is -2/5. So let's talk about that. What does that mean? If the vertical dilation factor is -2/5, what's that doing? It's telling us that we're going to multiply our original vertical distance from the vertex by 2/5. Okay? So let's find one that does that. Let's just identify, we'll just check them out, the ones that are at the right places. So -5, -2. So there's -5, -2 right there, agreed? Okay, does this do what it's supposed to do? Does the dilation factor work here? So we would know that normally, let's think about this in terms of our parent graph. Normally, if we go over by 5, right? So if that's 5, how much would we normally go up?
2.
Normally on the parent graph, on just a regular absolute value graph. If I go over 5, if I was just going to draw the normal absolute value V, I go over 1 and up 1, over 5 and up 5, right? So normally we would go over 5 and we'd go up 5, and we'd have a point right there. And our graph would just do, and we go back 5 and up 5. And our graph would just do that, right? That's our parent graph. We always want to compare what we end up with to the parent graph that we started with, right? So that's our initial. Our initial value is +5. Well, what do we get? When we go over 5 for this function, we go down 2. So that's our final, right? Did it do what it's supposed to? Is final divided by initial -2/5? It is, isn't it? So that's the right graph, right? And you kind of think about it qualitatively. Did it do the right thing? Well, 2/5 ought to be shrinking, right? Which it did. It compressed it vertically, and it flipped it because it's negative. Everybody see that? Okay, so that's the one that fits, isn't it? Okay. The other way you can think about that too is if this is what we started with, if I multiply my original vertical difference by the dilation factor, -2/5, 5 times -2/5 is -2, isn't it? right? So it did what it was supposed to. Okay, so that's it. Let's try one more of those, and maybe let's do a square, or a, square root one.
Then do you think we could go computer lab?
Yeah, I mean, yeah, we can, if you guys think, do you think that's the most helpful
I like
thing?
to try after you teach us, otherwise I just forget.
Okay, let's do one of these and then we'll call it good. We'll go to a lab. How about, let's try one like this, maybe.
Great problem.
Okay, what about that? That's a good one. Let's try. If we can do that one, we can do any of them. That's a pretty tough one. Okay, Anna, tell me, what are the H and K for this one?
-1, -5, -5.
-1, -5, very good. Oops.
2 negative.
Okay, what else do we know? Do we know A? I mean, what's A here?
1,
So A doesn't do anything. What's B?
-1/9.
-1/9. Okay, so if B is -1/9, then what does that tell us about the horizontal dilation factor?
That's the same.
-9.
Whoa.
Because remember, the horizontal is the one that flips. Horizontal dilation factor is the reciprocal of B, which is -9, okay? So then what is this gonna do horizontally? If the horizontal dilation factor means what we're multiplying by. We're actually multiplying by -9 horizontally. What are the two things that are happening horizontally? What's the 9 part mean? So when B is -1/9, we're going to, horizontal dilation factor is -9, so are we stretching or compressing horizontally? Stretching, yeah, because we're multiplying our horizontal distances by 9, which makes them bigger. What's the negative doing? Brendan, what's the negative do? The fact that the dilation factor is negative. The 9 stretches, what does the negative do? Okay, but in this case, it's gonna, you're right, it's gonna flip it, but now we're talking horizontal, so it's gonna flip it horizontally, right?
So flip that way.
So it's gonna, right, so it's gonna open up, instead of going up to the right, it's gonna go up to the left, right? It's gonna get flipped horizontally over over the special point, okay? So we gotta go find this guy then. So -1, -5, okay, that's the right vertex, isn't it? Is it doing the right thing? Normally, our parent graph would start at the vertex, it'd go over 1 and up 1, right? So this isn't doing the right thing, is it? This one didn't, it just got flipped, it didn't get stretched. Everybody see that?
Yep.
Okay, so that's not it. Keep looking. -1, -5. Okay, so there's one right there. Let's try this. So now this one, it's in the right spot, but normally if I go up by 3, I would go over by how far on my parent graph, a square root graph?
3.
No, 9, right? Because this is, remember this, the square root graph's the one that curves off to the, kind of flattens out. Because the inputs, the horizontal distances, we're going to square root those to get the vertical distances, right? So we would have, if we go over 1, the square root of 1 is 1, so we go up by 1. If we go over 4, the square root of 4 is 2, so we go up by 2. Over 9,
3.
we're going to go up by 3, exactly.
Oh,
See what I'm saying?
Yep.
So that doesn't look right, does it? That's not a reflection. See what I'm saying? We didn't stretch that out, did we? Normally, we would go up 3 and we'd go over by 9. This time we went back by 1, and so we actually compressed that. We multiplied by -1/9 instead of -9 in this case. Everybody agree? So that did the opposite. That's not it. Oh, I should have erased all that stuff, right? Let's keep looking.
Bingo.
Almost. This is the wrong, not the right vertex, but we're getting close.
There it is.
There it is, right? Now that one makes sense, doesn't it? Look at this one. Okay, on this one, we start at the vertex. Normally, we would go up one, because look, at this point that they've picked here is up by one. Normally, we'd go up by one and over by one, right? So it would look like that. So we start with positive one, and we end up, that's our initial horizontal distance. Our final horizontal distance is -9. That works, right? So final value divided by initial is -9/1. Yeah, that's it. That's our dilation factor, isn't it? Right? So it did what we expected. It flipped it and it stretched it by a factor of 9 horizontally. Okay? If you can do that one, I think you can do any of them. Okay? Should we go practice?
Yep.
Okay, let's go to 332.